in this problem, we explore the idea in mathematical logic called contrapositive that states that if some event A implies, if A implies B, then not B implies not A. So this is a statement in mathematical logic. We need to prove something similar in probability. So here's what we're trying to show. We're trying to show that if B implies A, meaning the probability of B given A is 1, then not B, so the probability that then not B implies not A, meaning probability of A complement giving B complement is also 1. Not B implies not A. And we're also given that A and B are events such that their probabilities are not 0 or 1. So to prove this, we're going to use Bayes' rule and the law of total probability. So we're going to rewrite the probability of B given A as the prior probability of B times probability of A given B. Using the law of total probability, we rewrite denominator as probability of B times probability of A given B plus probability of B complement times probability of A given B complement. Now, we're given by assumption that this expression equals to 1. Notice that these two terms, the term in the numerator and this term in the denominator, are the same. So for this ratio to equal to 1, this term here needs to equal to 0. So probability of B complement times probability of A given B complement needs to equal to 0. Now we're given that probability of B is not equal to 1, which implies that probability of B complement is not equal to 0. So we have two real numbers here whose product is equal to 0, and one of which we know is not 0. That means the second one has to equal to 0. So probability of A given B complement has to equal to 0, which implies that probability of A complement given B complement has to equal to 1. And we've proven what we set out to prove. So now let's consider part B. Part B says, what if A does not imply B, but it almost implies B? So probability of B given A is almost equal to 1. So can we say that not can we say that not B almost implies not A? Can we say that probability of A complement given B complement is almost equal to 1? So this is the question we need to answer. Can we say that? So let's consider events A and B such that they are independent. So A and B are any two independent events with the constraint given by the problem that their probabilities are not 0 or 1. So they're independent events. Now, what does this imply? This implies, so probability of B given A being approximately 1, and the fact that B is independent of A implies that the prior probability of B was already approximately equal to 1, which in turn implies that probability of B complement is approximately equal to 0. Now, because probability of B complement is approximately equal to 0, because the probability of B complement is approximately equal to 0, we can say the following. We can rewrite. Let's rewrite probability of B given A here. So again, Bayes' rule. We have probability of B times probability of A given B over probability of B times probability of A given B plus probability of B complement times probability of A given B complement. And we know by the assumption of the problem that this is supposed to be almost 1. Now the fact that we just said probability of B complement is almost 0, that means that this term here, probability of A given B complement, can be large. and by large we mean almost 1. And their product will still be very close to 0 because the probability of B complement is really, really close to 0. It drags this product back down to 0, so the total expression is still almost equal to 1. And now because probability of A given B complement can be large, this implies that probability of A complement given B complement can be small, meaning approximately 0. So we started by saying that A almost implies B, and here we're saying that B complement does not actually imply A complement, does not even almost imply A complement. In fact, the probability of A complement given by B complement can be very, very small, close to 0. So in the case where A almost implies B, it doesn't exactly imply B, but almost implies B. If A and B are independent events, we have this issue arising, so we cannot make this statement here. So the answer to this statement is no, we cannot claim this.